You're deep into a coding task, right?
Oh, yeah, we've all been there.
The flow state is, absolutely perfect. You probably have about 50 tabs open. That complex API integration is finally making sense in your head. You type out the final command for your terminal. You ask Claude Code to write the function. You hit enter.
And
suddenly, boom, you get a really cold, hard error message. You just completely ran out of AI credits.
it feels like hitting a brick wall. You're going at 60 miles an hour. You are just so close to the finish line.
It really is a brutal wall to hit.
It almost feels like a nasty subscription trap. You're heavily tempted to just pay a little more. You just really want to finish the job.
I completely agree. Welcome to the deep dive. We are genuinely so glad you're here with us today. Okay, let's unpack this.
Let's do it.
Today, we're looking at a comprehensive guide on managing Claude Code costs. We will explore why those costs sneak up on you so quickly.
Yeah, they really do sneak up.
We'll dive into the actual mechanics of prompt caching, and we'll cover the specific commands to keep your credits from draining.
This is a vital topic for literally any developer, especially if you use command line AI tools. Those API costs can spiral incredibly fast.
Right. So we need to start at the root of the problem. We have to understand what we're actually paying for. We can't optimize the system otherwise.
That makes perfect sense. The fundamental currency we are dealing with here is tokens.
Words or code chunks the AI reads and writes.
Exactly. Now, most of us know tokens are the basic processing units, but we often treat them like unlimited tap water.
Yeah, guilty as charged.
In Claude Code, they act way more like a taxi meter, and that meter speeds up the longer the ride goes on.
That's a really great way to frame it.
The critical thing to grasp is the asymmetric pricing structure. Output tokens almost always cost more than input tokens, but the real hidden danger isn't just the output. It is the dangerous illusion of a short prompt.
Let's explore that illusion a bit. I type a short question into my terminal. I use maybe 5 or 6 words. Naturally, I assume the transaction is super cheap.
You would definitely think so. But Claude isn't just reading that one tiny sentence.
Right.
It's processing a massive amount of hidden context behind the scenes.
2-sec silence. Right. The invisible baggage. I always assumed the AI just looked at my current active file.
Not at all.
It's actually pulling in the entire conversation history.
Yep.
It reads multiple file contents. It parses all your recent command outputs.
Yep.
It scans your entire costsWhen.md file. It looks at loaded skills. And it constantly processes overarching system instructions.
It carries literally all of that every single time you press enter.
Wow.
So even a tiny follow-up prompt can be incredibly expensive. If your coding session has been running for hours, it's bad. The model processes all that background data all over again.
The common analogy is stacking Lego blocks of data. Every prompt just adds to the tower. But I feel like it's actually worse than that. It's like carrying a massive Lego tower with you. But you have to physically inspect every single block. You have to check them all before you're allowed to place the next one on top.
That's a remarkably accurate visual. The tower just keeps growing in the background. You don't actively see it, but your wallet is paying the toll to carry it.
So let me ask you this. Why do output tokens cost so much more than input tokens?
It comes down to the underlying architecture of large language models. Reading data, which is the input, can be heavily parallelized.
Okay.
The model processes those tokens simultaneously. It is highly computationally efficient. But generating brand new reasoning and code, that is an auto-regressive process.
Meaning it happens one step at a time.
Yes, and that requires much more active processing power. The model generates one token, feeds it back into itself, and generates the next.
Right.
Generating takes real computational heavy lifting.
But generating new text is much harder than just reading it.
Yes. Generating demands continuous sequential processing power.
Building directly from that heavy burden of context. If reading old context is expensive, how do we mitigate that cost?
We make the AI remember the context for cheaper. We leverage something called prompt caching.
Let's clarify how that works. Saving past data so the AI remembers it instantly.
Precisely. And Anthropic notes this feature is a massive game changer for developers. Cache read tokens cost significantly less than normal input tokens. Sometimes they're up to 90% cheaper than starting from scratch.
I saw some users on X talking about this exact workflow. A developer named DXR explains it beautifully. He says it dramatically reduces both cost and latency.
What's fascinating here is how much it scales. Another user named Truffle notes a very similar experience. Cache hits stretch your usage allowance much further than cache misses.
Right.
It is basically the secret to making your daily quota actually last.
Yeah, wait, whoa. Imagine caching massive enterprise code bases instantly without reprocessing, just having gigabytes of context sitting there, perfectly primed and ready to go.
It really is magic when it operates correctly. The speed difference is incredible. You ask a question about a massive repository, and the answer feels instant.
That sounds ideal.
It is, but there is a real danger lurking here.
Yeah.
The cache is actually quite fragile.
Fragile in what way? What actually breaks it?
The cache relies on strict sequential matching. It uses something called prefix caching. The AI stores a continuous mathematical representation of your context.
Okay, follow.
If you change anything at the beginning of that sequence, it's over. The prefix corrupts the entire chain that follows.
It just dumps the memory and starts over from scratch.
It has to. Changing your setups forces Claude Code to rebuild the cache entirely. If you tweak the cache prefix mid-session, for example, it ruins your savings.
Ouch.
The AI has to process that giant Lego tower from scratch again.
What is the most common mistake people make that breaks this cache?
Fidgeting with their environment variables. People change their settings or tweak system prefixes mid-session. They do this when they don't absolutely need to. They think they are optimizing their workspace, but they're actively forcing cache misses.
Basically, don't change your settings if you don't have to.
Exactly. Keep your hands off the configuration dials once you start working.
But we know caching doesn't last forever. Sessions inevitably get bloated over time, regardless of cache hits.
They always do. The context window eventually fills up. The Lego tower gets too tall and unwieldy.
So we have to actively prune the history. This brings up a really fascinating psychological barrier. How do we drop the baggage without losing our progress?
The guide outlines 3 specific commands for context management. The first is a simple command, /clear.
Right, I know /clear. It just starts an entirely empty context. But I have to admit something.
Oh, yeah.
I still wrestle with holding on to old context myself. I'm kind of a bit of a digital hoarder.
Yeah, you are definitely not alone in that feeling. It is a really hard habit for developers to break.
I always fear I might need that one random idea from an hour ago. I worry the AI will forget the nuanced architectural decision we made 20 prompts back.
We treat chat history like a safety net because human memory is flawed, but we have to learn to trust our actual code base.
That's tough.
If your codebase files already hold the current project state, the code speaks for itself. You just don't need the chat history anymore.
That requires a real shift in mindset. You have to trust that the code contains the truth. But what if the code doesn't explain the reasoning? What if I really need to preserve the why behind a recent change?
Then you move to the second method. You use the /compact command.
/compact. I've seen developers using that to shrink their sessions.
Yes. Claude Code essentially summarizes the current conversation for you. It's ideal for keeping reasoning or architectural decisions, especially ones that aren't visible in the syntax of the code itself.
The guide gives a highly specific prompt example for this. You type /compact focus on the API changes, key technical decisions, current bugs, and next steps.
Providing specific instructions to the compact command is brilliant. It gives the AI a clear, constrained focus. This ensures the resulting summary doesn't become too general or overly vague. It keeps what actually matters and dumps the conversational filler.
It effectively compresses the timeline. But what about when I'm done for the day? The third method addresses that scenario perfectly. It's called the handoff file.
This is an incredibly powerful workflow for cross-session continuity. You literally prompt Claude to create a markdown file. It's typically called handoff.md.
Let's walk through that scenario. It's Friday evening. I'm completely exhausted. I have half-finished functions scattered everywhere. I ask Claude to write the handoff file. What goes into it?
You instruct the AI to document the exact project status. You have it list all completed work from the session.
Right.
You meticulously list any unresolved bugs, failing tests, and clear next steps.
It's like leaving a detailed technical note for your future self.
Yes, exactly. Then when you start a brand new clean session on Monday morning, you just ask Claude to read that handoff.md file first.
It gets the new session up to speed instantly. And it does it without carrying 50 pages of Friday's conversational baggage.
It creates a clean slate while preserving your technical momentum.
How do you decide between using compact and just making a handoff file?
Compact is really for mid-session spring cleaning. It's for when you want to keep coding right now. A handoff file is for pausing your work entirely. You use it to pick up the work in a brand new session tomorrow.
Compact is for right now, handoff is for a fresh start.
That perfectly captures the functional difference between the two commands.
So we've cleaned out the chat history. Our context is pruned. But you could still be bleeding credits before you even type your first prompt. We have to look at your baseline environment.
A perfectly pruned history doesn't matter if your foundational setup is bloated.
Which brings us to model routing. Throwing the heaviest, most expensive AI model at a simple task is a massive waste of credits.
Model routing is rapidly becoming a mandatory developer skill. You simply cannot use the strongest, most expensive option for every single thing you do.
The guide suggests using Claude Opus for complex bugs. It's highly capable for architecture and broad project planning.
Opus is an absolute powerhouse. But once the plan is set, you need to switch to a lighter model.
Like Sonnet.
Yeah, use Sonnet for simpler execution.
It's kind of like hiring a senior architectural engineer to come paint your fence. The engineer will definitely get the job done, but their hourly rate is going to bankrupt you.
That is a hilarious and painful reality. Sonnet is fantastic for routine execution. It handles standard refactoring and boilerplate generation beautifully.
Right.
Reserve Opus for when you are truly stuck on a deep logical flaw.
We also need to talk about setup hygiene. Let's look at what's silently loading in the background. Your claude.md file shouldn't just repeat your repository data.
Your system prompts need to be relentlessly concise. If your markdown file endlessly repeats data the AI can already read in the codebase, you have a problem. You are wasting tokens on every single interaction.
Use the /context command constantly. It helps you see exactly what files and instructions are actively eating your token budget.
Another fantastic tool mentioned in the guide is the /doctor command. This actually comes as a tip from an internal Anthropic team member.
How does the doctor command work in practice?
You run /doctor to analyze your current workspace. It helps you right-size your included files. It reviews your configurations and helps you clean house.
Before you start racking up heavy API charges.
Exactly.
And then there is the very tricky issue of MCPs.
Model Context Protocol servers. Extra tools that let the AI do specific tasks.
Right.
They allow Claude to interact with your local environment, databases, or external APIs.
The guide strongly advises keeping MCPs and loaded plugins lean. It cites developers Milogy and Nate Herc. They point out that having too many active skills adds massive context overhead.
It is a huge strain.
Here's where it gets really interesting. I always assumed unused plugins were just dormant code on my hard drive. Are extra plugins really that harmful?
Oh, absolutely.
I mean, they are just sitting there. They aren't doing anything until I actually call them.
That is the most common trap developers fall into. They aren't just sitting quietly on your hard drive. They create constant, heavy context overhead.
I need to understand that mechanism better. Are you saying Claude is actively holding the instruction manual for every plugin in its active memory? Just in case I ask for it.
That is precisely what is happening. Even if you aren't actively using a tool in your current prompt, its instructions are loaded.
Wow.
Its functional definitions and parameters are injected right into the context window. It takes up highly valuable token space.
It's more that invisible baggage we talked about earlier. Claude has to process those tool definitions with every single prompt you send, whether you use them or not.
Yep.
So do tools you aren't actively using in a prompt still eat up your tokens?
Yes, they absolutely do. Loaded skills and idle MCP servers constantly occupy space in the background context. They slowly and silently drain your credits with every enter key press.
More tools mean less room for your actual project code.
Less room for code and a significantly higher recurring cost for you.
And before we wrap up today's deep dive, we're going to take a quick break. Sponsor. And we're back. So if we synthesize all of these tactics, a very clear golden workflow emerges for developers.
It really does. It requires continuous, intentional management of your workspace. Keep the cache warm by maintaining stable prefixes. Don't tweak your settings unnecessarily mid-session.
Prune your context early and often. Overcome the fear of deleting history. Use /compact or /clear before the session gets bloated. Trust your actual code base.
Route your highly complex planning tasks to Opus. Move your simple execution and refactoring tasks to Sonnet. And make sure to run /doctor to keep your background plugins incredibly lean.
So what does this all mean? As our personal code bases grow, and as AI context windows expand infinitely larger, things change. The ultimate skill for a software developer won't just be writing code. It will be mastering the exact, precise art of what to make the AI forget.
If we connect this to the bigger picture, that is a deeply powerful thought to end on. In an age of endless digital memory, intentional forgetting is a crucial feature, not a bug.
Thank you for joining us on this deep dive. We really hope this saves you some serious API credits this week. Stay curious and keep those context windows ruthlessly clean. OUTO Music.